been answered, so we have to go back and look at the shadow problem one more time. However, let me give a broad scope. Period 6, actually, yesterday someone raised their hand and said, oh, there's a part B to that problem. And I was like, oh, yeah, I forgot about that. So we have to go do part B, and we're like, wait a minute, we just did part B. 10/3 was part B. What was part A? That sometimes happens in the long answer. You do something like, I think this is the right answer. You go to the next part, and you're like, wait, that's what I just did, so I must have done something wrong for the question they asked. Anyway, we'll go back to the shadow problem in just a second, but broad scope. When is our test? Tuesday. Why is it not Monday? So many reasons. But what is due Monday? Oh, it's not up there. Sorry. The test review is due Monday. It's on Google Classroom. No stress. Why is the test review due Monday? The book review?
So we can talk about
it. We can go over questions and see where you're still stuck. Yeah? Today is ideally, in some way, shape, or form, a work day, but it's up to you as to what type of work day it is. I have had you write down 4 big conceptual, long answer type questions, so that I'm going to work through all 4 of them. You can work through them with me, but it's also going to be on the YouTube video, so if you want, you can just work on your book work. Some of you guys, especially going on retreat, you're like, I just want to go get a textbook and work on my homework. Cool. Remember the test review, no directions, no problems, just work on the, just show me your work and the answers, and that's enough. So if that's the best use of your time, go for it. In just a second, go grab a textbook or open up your Google Classroom. I don't think I have the textbook pages in there, but it at least has the homework numbers. And then you can check in with this later and use it as a review Sunday night or Monday night. But I'm going to work through these, talking through them. If you guys are working on your test review, I don't really want you talking to each other. Just kind of work on it individually. But are long answer problems the only types of problems? You guys got your bonus practice test, right? What do you see? Long answer-ish stuff. Hey, there's a related rate for like all the different categories that we usually do, right? Maybe I'll do that on the test too.
Yes.
There's related rates. There's a long answer like mathematical one. Hey, it looks like that 4th one with the inverse and the F inverse prime. Anyway, but what's up here? Multiple choice. Short answer and multiple choice are very different. Multiple choice, make it match. Multiple choice, but how many are there? 3. My test is going to have like 12. Okay. I made the practice test relatively short because these, oh, you see that thing? It's a FRQ, it's a long answer one. It has an A and a B and a C and this whole paragraph of information. Oh, that's okay. We've been seeing paragraphs and related rates. No stress. Okay, anyway. There's an FRQ. Remember, the practice test, the bonus practice test, isn't there an answer key online? Okay. So, only 3 multiple choice. That's not, wait, your book reviews. Does your book test review usually have tons of multiple choice, or is it more just kind of like work it out? Okay, so wait, that's a dilemma in the sense that we probably need more multiple choice practice. Now, I know some of you are very limited on time. So there is no other required work besides the book test review, and the practice test is bonus. These 4 problems I'm doing just because it's the big, like, conceptual calculus skills. They're the 4, like, I don't know, the 4 main calculus skills you need to do as far as implicit differentiation, logarithmic differentiation, and then derivatives of inverses. However, whoa, what do you guys see right after these 4 problems in your notes? Okay, there's only 3 multiple choice on that practice test. That practice test is going to take time. So what have I done in your notes? And I'm going to post it just underneath, where do you guys want it? The test review practice test. I'll post it somewhere. Maybe I'll just post it as a separate post. Completely optional. You don't get any points for it per se, but extra multiple choice, check it. I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have 7 more multiple choice with their answers. Does that make sense? Mm-hmm. But this is just for personal enrichment because 3 multiple choice really is not a lot of multiple choice practice, and making it match, you could get stuck on different things. So the book test review is developing skills. These 4 problems I'm doing today is making sure you have the skills. And then remember, making it match can get tricky from the last test, right? So then I've given you like 7 extra multiple choice beyond the practice test that would be really good for you guys to do. But I know you guys going on retreat, you have limited time. So you kind of have to choose what you think you need to do. Let's not worry about that. That's your response. But there are a lot of resources at your guys' disposal in preparation for this test. So right now, if you're like, I just need to get into the book and I need to work on my book work because I have a really busy weekend, go grab it, work on your review at your desk. Totally fine. But I'm going to start talking through these 4 big questions. At the very end of class, we'll talk about the shadow problem. Sound good? Because period 6 already did the shadow problem. They don't need to hear it. And they're the ones maybe listening to this on Sunday night. Okay, here we go. 4 big problems. I'm just going to go. Remember, these are the skills. You have to have the skills. Ooh, we have a quiz on Monday, right?
That's not very big.
Forever quiz. But there's only 2 cards. Now, don't judge too much. I really want to rip it out and do it all over again. But if I rip it out and do it all over again, then I'm going to have 1 less page and it's going to be really annoying. Because each of these have 25. It's just the spacing is way off. I was like, yay, I have tons of, no, I don't. And I wanted like sine, cosine, because it's positive, negative, and I almost did like a plus, minus, but then that was going to be confusing. Okay, that's horrible and disgusting, and I'll figure out something. But that was for number 19, all the inverse trig, very easy to get confused, but only 6 things, really 3 things to memorize. And then we have the derivative of the inverse card. 2 cards, guys, right? And then bonus comes from old cards. You can do this, but don't underestimate. So many people mess up those inverse trig rules. Kyle, what was your question?
Completed cards or
I'll always have completed cards just in case, you never know. Okay, here we go. In order to do a tangent line, don't I need y minus y1 equals m times x minus x1? I have a 4. I have a 3. I need an m. How do I get an m? Of a tangent. Well, yeah, I need to find the derivative, and the way to find the derivative of something like this might be an implicit derivative, right?
Yeah.
So, let's just do 2x. Wait a minute, why don't I write dx dt?
Just you don't need to, because it's dx
It's
over
not a
dx.
t, it's dx dx. Good, keep going. Okay, but this one has 2y dy dx, and what's one of the most common mistakes besides forgetting your differential? What's the
Forgetting it's a
derivative of
constant.
25?
0.
0. I've seen multiple ones of you that made that mistake. Just careful. Subtract the 2x, divide the 2y, and we end up with negative x over y, but that's not what I'm putting there. Why?
You plug in x.
I have to plug in. It's a such that I need the slope at 4, 3. Not all the slopes, the slope. So I go ahead and plug in. Oh, negative 4 over 3. Dun, 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 dun. For a long answer, is that enough?
Oh, yeah.
Good. However, if it was a multiple choice, could they have gotten y by itself? Yes. Did they have to? No, not necessarily.
By all
They
means.
might have. They might have. We would have ended up with negative 4 thirds x, that'd be plus 16 thirds, and then plus 3, which is 9 thirds. 16 thirds plus 9 thirds is 25 thirds. Anyway, put that in parentheses though. Now, wait a minute. What's the next one after?
Normal.
So, like, not irregular? Help. Quick help for you. Normal means in math, specifically in mostly physics. Well, physics can also use the word orthogonal like we saw with vectors last year. Normal means perpendicular. Really? Mm-hmm. Comes from the Latin word, I think, if I remember right, from the BC book Normalis. I don't know if that's how you say it, though, but that's how you spell it. That means, I don't think it necessarily means perpendicular, but it alludes to it. Anyway, comes from Latin, but normal. Perpendicular. Wait a minute, perpendicular. Perpendicular. Going through the exact same point, but what changes? Not the point, but the slope, the slope. And how do you get a perpendicular slope? Flip it and?
Negative.
That's the reciprocal, but we also need opposite. So what's the opposite sign? Positive. What's the reciprocal? 3/4.
Go team.
Guys, these are 4 really important questions for the test. True?
True that.
So if you don't remember that normal is perpendicular, if you don't study that normal is perpendicular, life might be sad. Because look, it was so easy. Hey, what else do we need to do in this one?
Oh, true. Find the second derivative.
Find the second derivative. Now, this could be the general second derivative, or it could be the second derivative, like another question might say at a point, right? Okay, we're going to look at both. Second derivative, don't we already have do you see how I made it the same problem? Don't we already have the first derivative?
Yeah.
Okay. So if we had the first derivative, which came from how do we take the second derivative?
Multiply by d over dx. You derive d over dx.
Take the dx out would be the product. Yeah. No, but I understand. You're thinking put it good, just not multiply. Take d dx of what? I don't know, whatever you want to. What? Well, there are two different expressions of the derivative. This one's implicit, so you could take a derivative right now, but careful, you would need to use the product rule.
Disgusting.
Or you could take the derivative here and take a quotient rule.
But it's a little better.
Some of you like the xy, negative xy, better than the 2y dy dx. But either way, guys, whichever way you go, you're going to at some point have to take the derivative of dy dx. And what is the derivative of dy dx? Whether it's second d first, first d second, right there, or whether it's right here, it's
d squared.
hey, couldn't you, even if you forget how to write it, maybe find it somewhere on the test? And be like, oh, that's it.
Like right above?
Yeah. But on the test, it might not be there. I might just use the words and say that. Okay, equals bottom d top negative 1 minus top negative x. D bottom, wait, what's the derivative of y?
1 times negative.
1 times dy dx. All over bottom square. Can I stick it to the man, box it, and be done?
No.
No, because who needs to be substituted in?
Negative x.
Yeah, dy dx. Remember this one? You have to go back, figure out who he is, and plug it in. Now, if I just want the equation, if I don't give you a point, you have to make it look nice, because it's going to be a make it match. I can almost guarantee. Okay? But pause. If it was a point problem, how could you kind of cheat the system?
Cheat.
Do you have to make it look nice first? Or could you go straight to the numbers? Which would be kind of nice, because then you're like, oh, hey, plug in, that was negative 4/3. I could put in negative 4/3, and I could put in a negative, positive 4. Now, some of you work better with numbers. So theoretically, if it was a point, you could just plug in and then get like all your numbers nicely simplified. But if it was something where it was an equation, like let's say the numbers weren't there, because technically they weren't. I just added them in for you guys to remember that was a thing sometimes. We'd have to make it look nice. So, because remember, no multiple choice answers will have complex fractions. We have plus x times negative x over y all over. Okay, guys, please, summer packet, get my trick down. How do you simplify a complex fraction? Multiply by? Who's stuck? Does that make sense, though? You want to get rid of that guy. Yay, so I can just cross out, right? No, you have to write them top and bottom. Now I can cross out, right? No. Don't kill a seal. You have to distribute, right? Fractions, you multiply across. What's in my denominator? Oh, I should just forget that because I don't like it and I should go making matches. What if something simplifies? You might go matching to something just because they figured, oh, they'll be lazy and not actually work it out. Stop. Keep going. That's going to be a negative y squared, right? And then that's, ooh, the y's cancel there. Haha, but I still have a negative x squared. Dun, 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 dun. Wait, y is the right answer, and you would have gotten it wrong if you didn't choose it. Negative 25 over y cubed.
Plug in.
Look up. Andrea's looking up. Whenever there's something magical that happens, now wait, is there going to be something very similar to this in the multiple choice answers? Oh, yeah. Maybe with like a plus? Right? It's not going to be right. It's not going to be right. They're not going to put a right answer, two right answers. No, but they could just be like a plus. And you're like, oh, well, I must have made a sign mistake. It looks close enough. Right? Right? But pause. Pause. What am I teaching you to do? What? That's not... Okay, so always just look up. Now, I'm not saying that'll always happen, but look up. In this problem, not forever, don't memorize it, but in this problem, x squared plus y squared was 25. Pull out a negative. Oh, stink 25. Dun, 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 dun. Okay? This was a thing. It was a thing back when we did the notes. It was a thing. It is a thing now. Okay. Why does this say use logarithmic differentiation, and on the AP it wouldn't even tell you that it is required? Not nice, but required. What is logarithmic differentiation? Rewrite with an ln first. Why the heck would you do that? Well, in homework we saw that if it's ln of something nasty, you can use the product and quotient and power properties to split them all up into smaller ln's with easier derivatives, right? Pause. What's the derivative of ln of u?
1 over u times u prime.
1 over u times u prime. A few of you guys on the chain rule test totally forgot that rule. But coming back. Why did you have to put in, it was not there, an ln in this one?
Because you can't get 2 over x.
Variables to variables, there is no rule for. Oh no, power will just bring, no, he's not a constant. Oh, boo bim boo, b to the u, just no, that's not a constant. The only way to properly deal with an f to a g, a u to a v, a variable expression to a variable expression is put in an ln and bring it down. But guys, why am I going to highlight this? And why am I going to make it black, not red?
It's just rewrite.
It's just rewriting. What have I not done yet?
Right.
You don't see any dy dx's, do you?
No, man.
Me either, because we haven't done it yet. So, d dx. What's the derivative of? ln of y. You just told me the derivative of ln of u. ln of y is 1 over y times u y. Yeah, dy dx, which is u prime. And then we have, oh, okay, rewrite that to be, this is easy, 2x to the negative 1 times ln of x. I got it. Bring down the negative 1, x to the negative 2, and then the derivative is, haha.
Well,
good. Stop me. Get mad at me. I'm showing what you guys do a lot of the time. You're overwhelmed with the problem, you've done so much work, your brain gets tired, and you're just like, ha ha ha, that's a power rule. Done. What did you totally, illegally forget? Slash read out.
I'm not adding anything.
Who keeps forgetting product rule? Times. The only legal way to proceed is product rule. Second. Got him. Be first. Now. Plus first. Got him. Be second. Be careful, guys. If you have to make it match, remember, 1, this is not a proper answer because dy dx is not isolated, is not alone. So I'm going to go ahead and multiply that y on the other side. Move them up. But then I also need to probably rewrite it if I'm making it match. So rewriting, anytime you see a negative exponent, what does that mean? He goes down, send him down. Wait, there's an x times an x down there, isn't that squared? What's the last step that a make it match might do? You guys remember? And these ones we have to look back also. Who was y? X to the 2 over x. Now, I guess they could do something snazzy if they really want to be a punk. What happens here? If you see this answer, but you have this answer? Okay, yeah, I get that. Oh, 2 fractions became 1. Guys, how do 2 fractions legally become 1?
Common denominator.
Okay, so common denominator. He would have needed an ln. Oh, it would. I guess you could have pulled a negative 2 out also. Okay, they could play with it. I don't know. Ooh, they could have put the 2 up to make it a square. That would be neat. Anyway, there are different things they can do, especially with ln's. They can play around with stuff.
Wait, why is that ln at the bottom?
Oh, he wasn't, but he was here.
So like,
Oh.
that ln?
I don't know, so I have major issues with it. No one else caught it?
Good job, Mariah.
I'm getting rid of this one.
Who was supposed to go down?
2.
No, not the
X
2.
squared.
Some of you will put the 2 down. You did in the last test. Not him. Just him, right? That's 2 to the 1. Struggle. Oh, wait a minute. They definitely would have put that together then. So that would have been 2 minus 2 ln of x all over x squared. I feel like they would have pulled the 2 out to the very front. Or, once again, they could have made that 2 a power and made it x squared. I don't think they would have brought up the negative 2 and made it 1 over x squared. That was like 10. That's fine. For most of you, make it match. We have one more big idea. So we've had implicit differentiation. Second, derivatives of implicit get kind of hard. You have to remember that whole dy dx, go back and find them. We have logarithmic differentiation, and we have to have that whole like, hey, maybe we have to go back and do some plugging in like at 25, or go back and plug it in like the y. What about this guy? Check out the directions and check out A. They want f inverse prime of who? 2. Okay, come on, follow your forever card. F inverse prime of A equals 1 over F prime of B. So the question should be, well, wait a minute, hold on. So A is an x of who? Remember our function notation? F of x or F inverse of x? Isn't A an x of the function or the inverse? Remember, I'm trying to think of my points. Because he has a point and he has a point. Because I'm dealing with f, so I have to think about him. But I'm also taking the derivative of f inverse. I have to think about him. So hold on. Remember function notation. This isn't times a, it's of a. And what's the of always? What kind of variable? X. So whose x? See it? It has to be the inverse is x in this context. Okay, so if it's the inverse is x, what is it of the original? Y. Because x's and y's switch. So when I'm trying to find b, don't I need to go take my f and set what equal to 2? See it? This is f, yeah? Who's f? This guy. What do I know? Well, I know that b is my x when 2 is my y. Do you guys agree? That's how we use the point. B is my x when 2 is my y. Oh. What do I need? B. Why? Because my formula needs it. I need to plug it in. Now, do I also need my derivative? Yes, I need my derivative also. Okay, maybe we should think about f prime in a second, but I'm guessing that's not too hard. Guys, what's the struggle with this? If I actually need to find b, is it a quadratic? So even if I do move the 2 to the other side, it's not a quadratic, which means so we have to do some vec division, long division, possible rational roots theorems from last year, and how to factor a cubic polynomial. Too much work. Too much work. What did I tell you to do? Plug in. Trial and error.
Plug it in,
Plug it in. 0! 0, 0, negative. No.
1.
1 plus 2 is 3. 3 minus 3.
Hey.
Yeah? Trial and error. So make a quick note to yourself, yeah? Trial and error. You are not supposed to be solving these with, like, big, long, crazy pre-cal. No. This is, like, probably a multiple choice question. There must be a fast way. The fast way is it's something nice and short and sweet. We have that one weird square root in our homework where, like, the 0s, 1s, 2s were all imaginary numbers. We, like, popped up to 6 and then 7, 8, 9. But besides that, start at 0 didn't work. 1 does work. B equals 1. We know if B equals, then I'm doing 1 over f prime of 1. What do I need now? F prime. Oh, okay. So come back here. F prime is equal to 3x squared plus 2. So don't I get to come down here and say, okay, so 1 over 3 squared plus 2, 1. Because that's my B. Go was a long answer, box it and you're done. If it's make it match, well, you better multiply. PEMDAS says that's a 1 times 3 is 3 plus 2 is 5. Dun, 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 dun. Are we okay?
I'm sorry, I just thought about something. Yeah.
I got very excited. We'll just
Yeah.
let it go. Okay, guys, those are the 4 big skills, I would say, or at least the 4 trickiest skills of the chapter. Wait, but we didn't even talk about inverse trig. Why?
Because it's just plugging.
It's plugging in the rules. What do you have to know? The rules. What's on Monday? Rubber quiz on the rules. So I'm not going to go over plugging in now. Okay. Maybe it would be nice just to peek really quickly and see if there's a place that plugging in could get tricky. Let's look at the practice multiple choice real fast. There's one place plugging in can get tricky. Not plugging in, but making it match. No. Yeah, that's a good one. Okay, how about number 3? I'm not going to solve maybe I shouldn't. Just because that was like a whole other homework, right? We had some places where plugging in could get tricky. Let's say you know the rule. Let's say you're a rock star and you totally know that taking the derivative of sine inverse, remember, arc sine is sine inverse, right? Of the square root of 1 minus 4x squared. Let's say you know the derivative of that is 1 over the square root of 1 minus u squared times u squared. But let's say you go to start to find it and you realize this gets kind of messy kind of fast because I have 1 over the square root of 1 minus who squared? Right? Wait a minute. Hold on. Is that really all that? The square root goes away. Oh, so as long as you don't kill a seal and you properly distribute that negative to both terms, maybe that won't be too bad except, why am I putting it times? How to take the derivative of something to the 1/2 power? Bring down the 1/2, and then what's the new power going to be? Subtract 1. Why am I putting another times? Peel off the square root. What's inside the square root? Which has a derivative of negative 8x. And we have to make this like match? If you guys go about simplifying this dude down, 1 over 1 minus 1 is 0, minus a negative 4x squared is a positive 4x squared. And then I have my 2 and my 8 become 1 and 4. I have negative 4x all over the square root of. Not there. Sweet. None of these. Can't this simplify? Why am I going to write a 2 and an absolute value of x? Because the square root of a squared is an absolute value in all technicalities. Hey, the 2 and the 4. That's cool. That's 1. That's 2. It still doesn't match. Doesn't it? Wait, does it? Oh, yeah, it does match. Just kidding. I thought they would try to simplify. They could have actually gone one step further. I'm surprised they didn't. That's interesting. Oh, no, you couldn't have. Yeah, you're stuck. You can't get rid of the x's because then it gets rid of the absolute. That's one way it can get weird. The other way it can get weird in your homework was if you were doing something like cosine inverse of 1 over x, because then you would have this weird, like, you guys remember you had a fraction within a fraction? There was one of these in homework where your u was a fraction and you had to simplify. That's how else it got nasty. But otherwise, you just need to know the rules and plug and chug. If there's something nasty in the u, go back to that homework and check it out. Section 2.6b. Every now and then, the making it match got a little weird. Okay, but besides that, those are the 4 skills. So what else is there? Related rates. If you guys want to go peek at that shadow problem one last time, maybe it's in your homework spiral, maybe it's in your notes. Why, oh why, oh why did I say we did something wrong? Letter A in this problem asked us explicitly to find the rate at how fast the tip of the shadow was changing. And so then once period 6 was like, hey, but there's a letter B. Question, what's letter B asking? At what rate is the, at the exact same 10 feet, that's good because this was 10 feet also. At what rate is the length of his shadow? Oh, wait a minute, guys. Which one shows, denotes, signifies the length of his shadow? That's what I just did. Ugh. That was B. If that's B, then what the heck is A? dxdt, that's the, oh, that's how quick the length of the shadow is changing. Letter A said the tip of his shadow is different. If we were talking about the man, which is one little like position, the man moving at a rate, what did we make that rate? dy dt. Why? Because the light pole is staying constant and the man is moving away, so we could measure him with this like stationary object. We could measure his rate as the distance from the light post. Ooh, so where would the tip of the shadow? This one was asking for d x plus y dt. You might be like, what? Yeah. But how do I take it apart? Take it apart. Take it apart. The same thing. I'm trying to find this such that t equals 10. No, something equals 10. He's 10 feet. Y equals 10. How am I supposed to? Oh, wait. Isn't this d dt of x plus y? Technically, right? They want ddt of d box d who? D this guy. They want the tip from the stationary object. Well, how do I take a, hey, isn't this just implicit? Wouldn't that just equal 1 dx dt plus 1 dy dt? Oh, and we know dy dt. That's 5. And what did we just find dx dt to be, even though it was the question earlier? So the weird thing is, in this problem, the easiest way to do it, I believe, would have been to do B first and then use it for A. They did it a different way, where they named that X, they named this Y, and then they went ahead to the next one, did Y minus X. I don't know, I kind of liked how he was a certain distance from the light pole, I made that Y. But anyway, sometimes that happens in an FRQ. You start doing something and you realize it was actually letter B and you have to go back and figure out letter A all over again. But on an actual AP, you wouldn't like go crossing it all out. You'd be like, hey, refer to part A, and then switch the answers anyway. So you don't want to waste time. So I want you guys to see that quick little mistake that we made, or at least we didn't finish the problem, so we didn't find the mistake. And we still have 10-ish minutes, 5-ish minutes, 6-ish minutes. What do you guys want to do? Some of you are working on the review, some of you are just chilling. Do you want to play with like one of the long answers on the practice bonus test, or do you want me to go play with some practice multiple choice, or do you want to? I can project the book up on the screen and start the review for those of you who don't have it. Any strong opinions? Which one? 4? Okay, we can play with practice testing before. I'll get ready.
Are they like proportional when it's coming to the
Okay, I want to play with my webcam anyway, so let me go peek at getting the practice test. There we go. But then you were talking about the test review, right, Adam?
No, on the back.
Oh, on the back. 5-minute bell, that's weird. Yes, they're similar 3-dimensional shapes. So if you guys want, Adam's helping you out on this long answer in the back really quick. He's saying, wait, does that whole similar proportionality thing work with three-dimensional figures too? If I was to make this a triangle, and I was to make this a triangle, like just like a slice through, they would be similar triangles. So therefore, if I'm saying, or this is showing up here, the diameter is 10, and the height, that's diameter, right? And the height is 10 of the object, right? Then what can I say down here? 2, H and D. I can say D is equal to H because of the shape of the container. Yeah. Yeah. Wait a minute, but it looks like R might be important because they labeled R not D. So guys, how could I reword this just a little bit in a way that might be more helpful? Yeah, 2R is equal to H. Do you remember yesterday that there was a way to go where we just started blindly taking a derivative, not thinking about what we had or didn't have and had too much, and we had to come back and look? There was another way, too, to figure out who we want more, R's or H's, and get rid of whoever we don't want first so that he's not in the way. Guys, can you just read through the beginning paragraph real quick? Can you tell what variables we're going to hold on to? Yeah, I'm going to hold on to height, because don't they tell me about a dH/dt? Do you see it? So I want H. Well, if I want H, then I think I'm going to get rid of R, because forget him. They don't really give me a clue. And if I can get this all in terms of H, check it. Couldn't I 1/3 pi times H over 2? Oh, that's still a nasty product rule. We'll just keep rewriting. Can't I keep rewriting this formula so that, okay, that'd be 1/4 times 3, that'd be 1/12 pi. Ooh, I don't think I mind this derivative very much. You see what I did? By using this relationship of diameter and height of the container being congruent, so therefore diameter and height of the water level will also be congruent, by using it to figure out R and H's relationship, I can get rid of R. Have a nice little... Isn't that just a constant and a power rule? Over here, I would have had to do a product rule, and I would have had a dRdt I didn't know what to do with unless I came over here and took a derivative. But right now, dV dt is equal to, bring down the 3, 1/4 pi h squared dH dt. Awesome. Although I think you don't have to worry about that until letter B, because only in letter B does it start to talk about dV dt. In letter A, doesn't it just say find V of 5? Oh, look. I'm ready, though, because I have it in terms of H. Plug it in, plug it in. Whereas over here, I would have had to plug in 5 and say, oh, no, who's R? And then I would have had to do other stuff. But I bet that's going to help us. Sorry, that had us analyzing that long answer very quickly, which in some ways is nice for you guys to have tons of clues. But in some ways, it shortcuts the process of you struggling through what to do. But then, Andrea, you were saying number 4, yeah? Okay. So help me out, guys. To find f inverse prime of -1. What's my formula? 1 over those, yeah? F prime of B. Okay, good, good. Just write the B because then it tells your brain you don't know it. So then come over here and write your, okay, what do I know? What's -1?
F inverses A.
The F inverses A or the F inverses X. So what does that make that for F? So what don't I know? Right? Okay, so you tell me, what do you do with that information? Whether you're stuck in a plug-in with related rates, whether you have a dy dx in an implicit second derivative, whether you have an answer where magic seems to appear, you need to look back. You need to look back. I'm looking back. I know the y. I need to find the x. Pause. Do you think I actually, or the AP actually wants you to solve with a cubic trinomial?
Oh.
polynomial? No. So plug in. 0, 0, 0, negative 3. No. 1 plus 2 is 3. Minus 1 is 2. Minus 3 is negative 1. What was that be? Plug it in. Plug it. Find f prime. Plug it in. Is that good? Good job, guys. Alright, get out of here. I'll see you guys later. If you have any friends in period 6 that are going on the retreat and they do not check their Google Classroom comments, I have the practice test. It'll be here all day. Okay? PK, all of them. Make sure they get their practice test. Actually, she got hers. Gavin. I think Gavin didn't. Verona didn't. Gavin didn't. Well, it got buried under papers yesterday. Let them know it's in here waiting. Retreat people, be safe, have fun.